All right, ladies and gentlemen, we are on 3.2, and we're just going to skip over the warm-up problem. That's why we are jumping right here into this problem. It says at the 2004 Summer Olympics, Athens, Greece, the United States won 103 medals. They won 6 more gold medals than bronze and 10 more silver medals than bronze. Write a system of linear equations that could be used to determine how many of each type of medal the U.S. Olympians won. Let G represent the number of G represent, that'd be weird, represent the number of gold medals, and S represent the number of silver, and B represent the number of bronze. So we won 103 total, so we could say the number of gold plus the number of silver plus the number of bronze is equal to 103. Says they won 6 more gold than bronze. So if I had 10 bronze, I won 16 gold. If I had 8 bronze, I won 14 gold. So gold is the number of bronze plus 6. Then I had 10 more silver than bronze. So same idea. If I have 3 bronze, I have 13 silver. If I have 12 bronze, I have 22 silver. So the number of silver is bronze plus 10. All right, so we have a system here. It's got 3 equations. I have 3 variables. Now this one is set up really nicely for substitution. I have a G equals, so I'm going to plug that into the first equation. And I have an S equals, so I'm going to plug that into the first equation. Now word problems tend to, not always, but tend to have some type of a substitution to it. So I have G, so instead of G, I'm going to put B plus 6. And instead of S, I'm going to put B plus 10. And then I just carry right on with the rest of this. Plus B equals 103. So now I want to look for like terms. I have 3 B's, and I have a 6 and a 10, so plus 16 equals 103. So I want to go ahead and I'm going to solve for B. So start off by subtracting 16 to both sides. So 3B equals 87. And divide both sides by 3. And you get B equals 29. So now I'm going to plug that 29 in for B here and in for B here. So my gold is 29 plus 6. So gold equals 35. And then I'm going to plug it in for silver. Equals 29 plus 10. So my silver medals is 39. So we have found out how many of each medal we have. All right, so then we have problems like this where we have just a system, and these ones are not, I don't see like an X equals or a Y equals or a Z equals. So the thing with this, our hints are going to be elimination, elimination, elimination. Generally, not always, but generally, when you have a system of 3 variables and 3 equations like this, you are going to do elimination 3 times. So I'm just going to go ahead and delete those to make a little bit more space for us to write, and I'm going to shrink that down a little bit. There we go. All right, so we have to do an elimination with 2 of our equations to eliminate a variable and get 2 variables left. So if I look at this, I have lots of options. I could solve the top one for X equals and plug that in and get Y's and Z's. I could solve for Z equals in the top one. The middle one, I have a negative Y, so I could do some multiplication there. Oh, I could do the same multiplication with the X's and the Z's. I am going to eliminate my X term. Purely, that's just a choice, okay? So I need now to take 2 equations, and I'm going to take the top one and the middle one, and I'm going to eliminate X. So I need to take the top equation and times it by -2. So when I multiply the top equation by -2, I get -2x minus 4y minus 2z equals -20. Now I'm going to rewrite my middle equation. 2x minus y plus 3z equals -5. And now I'm going to go ahead and do substitution. I'm just going to add my 2 equations. My x's eliminate. I get -5y plus z equals negative 25. And that's exactly what I wanted, was to get it down to one equation with two variables. Now I need to take the top equation and the bottom equation and eliminate x, or the middle equation and the bottom equation and eliminate x. I'm going to take the top and the middle, or I mean the top and the bottom, just because I already have what that's multiplied out to. That's all. All right, so I'm going to multiply by negative 2 again. So I'm going to get negative 2x minus 4y minus 2z equals negative 20. That's just the top equation multiplied by negative 2, and then my bottom equation. All right, and I'm going to go ahead and add the 2 again. My x terms cancel. I get negative 7y minus 7z equals a positive 7. So now I need to take my two equations that are the two variables, and I'm going to put them together. Now, if I look at them, I can see which variable I want to eliminate. Some people don't see it and might need to write it down, but I get negative 5y plus z equals negative 25, and negative 7y minus 7z equals 7. All right, so in this, you are going to want to eliminate your z, because you have that plain z there all by itself. So I'm going to go ahead and multiply that top equation by a 7. Okay, and I'm just going to write it beneath. So I get negative 35y plus 7z equals negative 175. Yeah. So now I'm looking at this blue equation and this red equation. I get negative 42y equals, and that cancels out the z's. So equals, now I have negative 175 plus 7, and I get negative 168. All right, to get y by itself, you're going to divide negative 168 by 42, negative 42. And we get y equals 4. Now I have my y equals 4. So I'm going to plug that back into either one of the blue equations to determine my z. And I'm going to pick putting it into the top one because z is by itself already. So negative 5 times 4 plus z equals negative 25. So I get negative 20 plus z equals negative 25. So my z has to equal negative 5 then. So I'm going to add 20 to both sides. Now, once you have both your y and your z, you're going to plug both of those into one of your original equations, excuse me, and I'm going to pick my top equation. And the reason I picked that is because it's probably the most simple one out of there for me to look at. So I have x plus 2 times y, which is 4, plus z, which is negative 5, equals 10. Excuse me. So I get x plus 8 minus 5 equals 10. All right. 8 minus 5 gives me 3, so x plus 3 equals 10. So my x has to equal 7. My circle is a little off there, but x is 7, y is 4, and z is negative 5. The last thing is you can write this as one ordered pair, just like we have our x and our z. I mean xy, we have xyz in this ordered pair. All right, the first one usually takes the longest to get the vibe going. So let's go ahead and look at this next problem. It's we can eliminate our x, our y, or our z. And I look at it and I see that I have a positive and a negative y in the top and the bottom equations. So to me, that screams out, hey, this is easy for me to eliminate a variable. So I don't even need to multiply. 3x plus y plus z equals 0. And 4x minus y minus 3z equals 9. All right, So our y and our negative y cancel. So we have 7x minus 2z equals 9. All right, then I'm going to take my middle equation and my bottom equation because my middle equation, we still have to eliminate y. My middle equation is a positive y. My bottom equation is a negative y. So I'm going to times this bottom equation by a positive 2 so that I can eliminate that. So I keep the middle equation as is. And my bottom equation becomes 8x minus 2y minus 6y, or 6z, sorry, equals 18. So I get a 7x, my y's cancel, minus 8z equals 15. So these two equations come together, and I have 7x minus 2z equals 9, and 7x minus 8z equals 15. I'm going to multiply my top equation by a negative 1. And what's that going to do is going to give me a negative 7x in the top. And that's going to help me eliminate my x variable. So don't forget, guys, this is a lot. So pause the video, rewind it. Make sure that you take the time to write. This is at your own speed. All right, so those will cancel, and I'm left with a negative 6z equals a positive 6. So my z is negative 1. All right, plug it back into either one of the green equations. Doesn't really matter. I'm just going to pick the top one. Okay, 7x negative 2 times negative 1 equals 9. So 7x plus 2 equals 9. So I'm going to subtract 2 to both sides, and I get 7x equals 7. So x equals 1. Now I'm going to plug both of those. I see the first equation looks the easiest for me, so I'm going to plug it into there. So I get 3 times 1 plus y plus a negative 1 equals 0. So we end up with 3 minus 1, so 2 plus y equals 0. So that means that y has to equal negative 2. Oop, there it went. Y equals negative 2. So I get 1, negative 2, negative 1. That one took us a little less time on that problem. All right, the next two will take even less time. Whew. All right, so if I look here, I don't have an x, a y, or a z that's by itself that I could easily manipulate. So then I'm just going to look at this, and I see the 4 and the 6 in the x's, well, and in the z's, and so I'm just going to eliminate the x's. That's what I tend to go towards is the x's, but you can choose. So I'm going to make, what does 4 and 6 both go into nicely? And 24. So I'm going to times the top one by, oh, you know what? They both go into 12. Let's do 12. That's easier. All right, so I'm going to times the top one by a negative 3, just to make that negative. I'm going to times the bottom one by a positive 2. So I'm going to do the multiplications as I write them down. I get negative 12x plus 18y minus 12z equals negative 36. Now I'm going to multiply the middle equation by a positive 2. So I get 12x minus 18y plus 12z equals 36. Whoa, do you guys see that? All of my variables are exact opposites, so I get 0. And negative 36 and positive 36 gives me 0. Do you remember what happens when your variables eliminate and you get a true statement? Because 0 is equal to 0. That's true. Yeah, you get infinitely many solutions. Infinitely many solutions. That means that the lines all line up right on top of each other. See, I told you to be short and sweet. So let's see what happens in this problem. Okay, so again, not the greatest numbers to work with, but I'm just going to take the top and the middle, and I'm going to make them into 18. 6 and 9 both go into 18. So I'm going to take the top one, and I'm going to times it by 3. And I'm going to take the middle one, and I'm going to times it by a negative 2. So I get 18x plus 36y minus 24z equals, 24 times 3, 72. Okay, middle one times -2. Negative 18x minus 36y, oh my, plus a 24z, oh, that should say z, not a c, equals, 60. Well, I see the variables are all eliminating, so that's awesome. But on the other side, oops, that should be a negative 60. I get 12. That's not a true statement. So this is a no solution. No solution. When your variables eliminate and you don't get a true statement, that becomes a no solution problem. All right, so that's where we're going to end with today's video. Tomorrow you'll have a video to watch that is going to go through the 3 word problems, but today is just on those ones. Take some time to rewind and watch it again and reach out if you have questions.